Good day, everybody. I like these type of rational approximations to irrational numbers. Um, this is this is a fairly tight. I don't really prove it here, but this is pretty close. Log base 10 of 3. What that means is what is the exponent you have to apply to 10 to give a value of 3. Now we know this simple truth. 1 is less than 3 is less than 10. And if you remember the properties of logarithms, log base 10 of 1 would just be 0, right? Because anything raised to the 0 is 1, right? Okay, so you would put log base, and I'll just drop the base 10. I'm just doing it to be explicit, but log of 10, right, which is true. Now, this doesn't help us too much. It just gives us a sense of what's going on. We know the number, this number has to be somewhere between 1 and 10, right? And it is, but it's pretty close to 1/2. So you can tell that the logarithm is not linear in any sense. Log base 3 is closer to 1 than 10, and yet the logarithm is almost, it's approximately 1/2, right? But anyway, let's get busy showing the inequality. It's fairly straightforward. There's a few little tricks. So I write down a series of equivalent statements here. Log base 10, this is just our statement, okay? If you multiply through by 40, you still get an equivalent inequality, and also there's a property of logarithms that allow the exponent to drift around to the argument. Okay, that just follows from properties of exponents. All right, and then right here, log base 10 and these are just inverse functions is why this is true. In other words, if you exponentiate this, you get 10 to the 19th, and you get 3 to the 40th. Again, just raising both sides to the 10th power. Not quite like that. You exponentiate at base 10. Okay? Now, so if we can establish the fact that 10 to the 19th is less than 3 to the 40th, or equivalently 3 to the 40th is greater than 10 to the 19th, we'll be done. Now, this series of statements is true. I didn't write down all the justification right here, but notice right here I've got it down to a comparison between 10 to the 9th and 8 to the 10th. Well, notice that 10 cubed, I'll just write this, there's two of them actually that come into play. 10 cubed is less than 2 to the 10th. Now that's if you don't notice that, this is kind of a hard thing to prove. But 2 to the 10th is well known to be a 1024, and 10 cubed is of course 1000, right? Let me write 1024 right here, okay? So that explains going from here to here and how we could replace 10 to the 9th with 8 to the 10th in the inequality if you cube this. If you cube this, you just get this right here, okay? And also another important fact is that 10 times 8, and I'm writing it that way specifically. I'm not writing down 80 because we have a 10 and an 8 right here. But that's equal to 80, but that's strictly less than 3 to the 4th power, right? 3 to the 4th is 81. And that's one more than 10 cubed, which is, or that's one more than just 80, right? 3 to the 4th is 81, 8 times 10 is 80, so 81 is greater than 80. And that's essentially why this is all true. So we've proved it. We can write down QED. It all works out nicely. See, where did we get the, well, yeah, we just start out with a series of equivalent statements right here. Okay, I said this is our problem statement that we're trying to prove. All of this is equivalence. And so we're saying this is equivalent, but we still have to show that 10 to the 19th is less than 3 to the 40th, which we did right here. Okay, so we can write down QED. And you guys, one way to check it is just to kind of cheap out and check your calculator. But this is pretty close, I think. It's a pretty tight inequality, very, very close from a decimal perspective. But anyway, I'm going to be doing some more of these that are a little tougher. They can be harder if you don't get lucky and having these type of relationships right here with well-known numbers, especially when the numbers get bigger. 2 to the 10th is very well known in computer science, right? And it's easy to calculate by hand if you have to, right? So, the 2 to the 8th is 256. So multiply by 4 and you get 2 to the 10th is equal to 1024. It's not too bad. Okay, but anyway, that's all. Thank you for viewing.